The dependent t-test is used where you have one sample, a group tested on two different occasions, for example, pre and post-test results. This type of t-test is also sometimes called a paired samples or a matched pairs t-test. This is considered a within-group design. In this work example, we want to see if there is a difference in mean BMI pre and post an intervention. We're going to be looking at the variables BMI and BMI_2. While we checked these variables for the normality assumption in part A, we actually need to have a look at the mean difference to see if we can actually proceed. To do this, we need to compute a mean difference variable. So to do this, we come up to transform and compute variable. Our new target variable could be called BMI_difference. Remembering this must be all one word without any full stops. Left click on your post intervention and move that across into your numeric expression box. Click minus and then move across your pre-intervention BMI. Remember, if you don't like the way your variables are displayed here, you can right click and choose to just display the variable names. Once you've completed this, click OK. You'll see your syntax telling you the equation you have just run. And then in your data view, you'll see your new variable has been created. Once we have this BMI difference variable, we will now check this difference variable for normality. So we come up to Analyze, Descriptive Statistics, and come down to Explore. We move BMI difference across to the dependent list. Under Plots, we select No Box Plots, Normality Plots with Tests, and Histogram, and we deselect Stem and Leaf. We click Continue, and then OK. As you can see, we have 10 cases with 0 missing. Our skewness and kurtosis are fairly close to 1. And you can see based on Shapiro-Wilk, our significance value is 0.845, which because it's greater than 0.05, we know it's normally distributed, and therefore we can continue. We'll double check the histogram, have a look at the QQ plot, and these values are sitting quite close to the line. With a small sample size, this is what we would be expecting. So because we know that the difference between the two variables is normally distributed, we can now proceed with running our dependent t-test. Come up to Analyze, Compare Means, and come down to Paired Samples t-test. We're going to put our pre-intervention BMI across and into variable 1, and then we can put our post-intervention BMI. You can either use the arrow or left click and drag across to pair 1, variable 2. And a reminder that if you don't like seeing your variables in this way, you can right click and display variable names instead. Once you've put the pre and post intervention BMIs into variable 1 and variable 2, click OK. And in your output screen, the dependent t-test output will now pop up. In your paired sample statistics table, you'll notice that the BMI for the pre-intervention has a mean score of 26, whereas the post-intervention BMI has a slightly lower mean score of 25. There's 10 valid sample per BMI 1 and BMI 2, and you've also got your standard deviation there, which we'll be reporting later at the end. When we have a look at your paired samples correlations, it's showing 0.000. This is your p-value. This is telling you that there is a significant difference between pre and post intervention. We want to then come down to your paired samples t-test, and we're going to be reporting your t-value, your degrees of freedom, and your p-value. To report this information, we'd be able to say that there is a dependent samples t-test found there was a significant difference between pre and post-intervention BMI scores, with t being 5.812, degrees of freedom of 9, and a p-value of less than 0.001. We can refer back up to our paired sample statistics table, and you need to indicate the direction of this relationship, with the pre-intervention BMI of 26 decreasing to post-intervention of 25.